Hello, welcome back if you still haven't forgotten me. The reason behind my absence is mostly due to the fact that I was very focused on school, but now that it's over, I want to focus on the channel more and I want to finish Baby Routing as SAP to move on to functional analysis textbook. Alright, today we have this problem. So we have sequence AN that is non-negative for all terms, and we have series that converges using it. We have this sequence of series, which is essentially just truncated series of AN. We have to prove this inequality, and then using it we have to prove that the series diverges. Okay, so first of all, it is useful to know that R converges to 0, and that for every m greater than n, our m is going to be less than Rn. It's a monotonically decreasing sequence. Alright, now with that out of the way, let's move on to the inequality. So first of all, it is useful to rewrite it with sigma notation. So we start at m and we iterate up to n, and we have a k over rk here. Next, on the other side, it is helpful to represent Rn as Rm minus the part that we're truncating with the n. So we iterate up to n minus 1 from k equals m. We subtract ak here, divided by Rm. So we have 1 minus 1 plus that sum. Again, we have the sum from k equals m1 from k equals m towards n minus 1 of ak over Rm. Now, if we were to look at these two sums, you can see that the terms are really similar, except on the left-hand side, we have a term that is always greater than the right-hand side, plus the right-hand side will lack additional part of the sum. So it is in fact true that this inequality holds. I don't want to write too much. To get the point, I explain it, and hopefully I can fill up the rigor that I miss here. So now we have to do is that this diverges. Now I'm gonna do it through contradiction. Suppose that it does converge, so for every epsilon greater than 0 exists capital N, such that for every n greater than m greater than or equal to n capital, the sum ak over rk, iterating from k equals m up to n, is going to be less than epsilon. No absolute value because we're working with non-negative term sequence. Alright. So what we're going to do next is we're going to use the inequality that we deduced ourselves. And to prove this by contradiction, it is enough to show that this statement can be greater than epsilon or some n or m within this condition. Okay, so 1 minus epsilon greater than Rn over Rm. We get that 1 minus epsilon times Rm has to be greater than Rn for that to be the case. Now, the thing is, recall how Rn approaches 0. It means that we can pick epsilon and then pick m. Then we can arbitrarily increase n up until Rn is smaller than this value. So this diverge. Next we have this inequality and this series, so let's first show that this inequality holds. Well, first of all, let's multiply both sides by Rn and get an less than 2 times Rn minus 2 times Rn plus 1 times Rn, oh, that is under the root. Alright, now let's represent n as difference of Rn and Rn plus 1. Alright, so now what we can do is we can move all the stuff to one side. We have Rn plus 1 minus 2 root Rn plus 1 times Rn, and that's gonna be greater than 0, I think. Alright. Now using this, and this is basically the difference of squares, so square root of Rn minus square root of Rn plus 1. Oh, that's squared and greater than 0. That's gonna hold true whenever these two parts are not gonna be equal, and that's gonna be true for every n we pick. So this holds true. Alright. Now we need to show that that implies that this converges. Well, if we were to take the sum of Rk minus Rk plus 1 up to n with the k starting in m, then this is gonna be just square root of Rm minus square root of Rn, and the greater n we pick, the lesser is this part, so indefinitely converges. This thing converges, then this thing also converges, because it has terms that are greater, not greater, that are lesser than of this sum. So that's it for today, yeah? As I have said, for example, I plan to get back on track with my schedule. The absence was mostly related to me trying to fix my school aptitude, because I spent a lot of time I should have spent on doing my school assignments on videos, and my performance ended up suffering heavily. Not even because of like knowledge gap, but because I didn't bother to do assignments and papers. Now that school is over for the next few months at least, I have time for channel. So I do plan to finish this textbook within somewhat near time, to finally wrap up with analysis. Well, not analysis as a whole, but the very basics of it. So yeah, after this little absolutely irrelevant to the video rant that you may find useful, that's it for today, yeah? Bye.